So we want to graph this function. I first want to find hk. So h is always a number next to the x, opposite, and k is usually added or subtracted at the end. So hk for this one is simply going to be 1, negative 3. 1, opposite of negative 1 is 1, negative 3. And so I'm going to go put 1, negative 3 on my graph. So I'm going to go over 1, down 3. Now that's not part of my graph. That right there is just the center of the graph. I'm going to make my asymptotes. Through that hk, we are going to have a horizontal asymptote and a vertical asymptote. And then we got to decide the graph around that. Again, this dot is not part of the graph. Now the question is, I have one asymptote right here. That right there is a horizontal asymptote, and that right there is a vertical asymptote. So I want to write down the actual asymptote. Well, the vertical asymptote for VA is this one, and that would be going through 1, and that would be an x equals 1. Not a y equals 1, but x equals 1 right there. So that vertical asymptote will be x equals 1. Now, the horizontal asymptotes right here, that horizontally goes through y equals negative 3. So the equation for the horizontal asymptote is going to be y equals negative 3. It's important to be able to write the equations for your asymptotes. Next step, we have to find our a value, because our a value helps us figure out how the graph looks around these asymptotes. My a value is the number on top. So it's going to be 2. What does that mean for graphing? Well, what it means is from hk, we are going to go right 1 and up 2. And then go right 1 and down 2. And that will help us make our sketch. Right 1 and up 2, and left 1 and down 2. Sorry, I said right, didn't I? So those are our 2 beginning dots. Now, there are some extra dots we can actually put on this as well. We go right 1 and up 2, left 1 and down 2. But what we can also do to make another nice point is to go right 2 and up 1. There's actually a dot also right there. So let's stick that dot on. Which also over here, you can also go left 2 and down 1 is another dot. And the more you graph these, you'll get used to this pattern of how you have this new a. The a also gives you another value to get the curve. So the graph is going to kind of come down, hit through those 2 dots, and you're going to go along this axis. And that's what we're looking for. Right next to the asymptote, curves through, and that way. Right next to the asymptote, curves through those 2 dots, and up along there. That right there is the graph of a rational function. You have 2 asymptotes, and again, a is right there, and we just stick the other dot to help us get the nice smooth curve. So last, the domain. The domain here are the values that you're allowed to plug in. Now, there's one value here that has no dot. You cannot plug that value in, and you get an error if you do. And what you notice is there's a vertical asymptote right here, which means there is no value at 1. There are several ways to write this. You can say that your domain is all real numbers but x equals 1. That's one way to say it. It's everything but x equals negative 1. You could also put x is less than 1 and x is greater than 1. Or you could put interval notation, which is saying I go from negative infinity to 1, and from 1 to infinity. All 3 of these describe the domain. Just make sure you can understand, recognize any of those 3 ways to describe the domain. Now, what does domain mean again? Is values. You're trying to write all the values you're allowed to plug in, or which ones mess it up. So right here I put everything but. Again, because if you put in 1, watch what happens. If you plugged 1 into this function right here, watch what would happen. If you plugged 1 in, watch what happens. Plug 1 in. Don't you end up with 2 over 0 minus 3? And you can't take 2 divided by 0. You're not allowed to divide by 0. It's an error. you must have a number on the bottom of a fraction. You cannot divide by nothing. And so that is an error, and that is why you have this asymptote, and that's the picture of an error. So for this rational, first thing I want to do is find hk. Now, h is always the opposite of your x, but what's k? What's added right here? Well, it's nothing. So there's nothing there. Now, if you want to, could you put a plus nothing? Yeah, but whatever. Hopefully you realize this is just negative 2, 0. Because there is nothing added at the end. And what is your a value? Well, it's the number on top here. That's your a value. So it is negative 3. So what I do is I go and find negative 2, 0. Now that is not a point of the graph. That's just the point where my asymptotes are. They intersect. So at that point, I am going to draw my asymptotes. So HK is kind of like the crosshairs of your target. And you draw two asymptotes around that. And then your vertical asymptote for this one is x equals negative 2. And your horizontal asymptote is y equals 0. That's y equals 0. That's x equals negative 2. Now we use our a value to plot a couple points so we can make the graph. So at negative 3, means I go right 1 and down 1, 2, 3. So I'm going to dot here, and I'm going to go left 1 and up 1, 2, 3. So that would be right here and right here. Now, to get a little bit better curve, I want one more dot. So with A, you can also do right 1, 2, 3 and down 1. I could also put a dot right there, which is also left 1, 2, 3 and up 1. There's an extra dot you can squeeze on here, which will help you make a really nice, smooth graph. Now, if you question how'd you get that other dot, could you simply plug in numbers to the function up here to find a nice clean dot? Yeah, you could, but there's a little pattern to it that kind of does a sideways a value, kind of like a horizontal a value. With that said, now let's make our sketch. We go right up against that asymptote, hit our two dots, right up next to the asymptote. Remember, you shouldn't cross the asymptote. It's a boundary to help you sketch it. And then that one right there. Right there we have our graph of a rational function. Now if you look at this, do you notice a vertical asymptote, meaning I cannot plug negative 2 into the function. If you put negative 2 down here, won't you create a 0 in the denominator, erroring it out? So let's just write the domain. Well, there's three different ways to write it. You can write it any of the three ways. I'm going to write this one. X is less than negative 2, and x is greater than negative 2. You can write any of the domain restrictions or the domain notations. I wrote that one. You choose which one you want.